Yo, what's up everyone? My name's Dave and you suck at programming. Alright, today we're going to go over a fork bomb like we did before. If you have seen my previous episode, I talked about a fork bomb and how it works on a Unix system. Well, today we're going to go through it step by step, very slowly, with safeties in place, so we're not going to crash a machine, we're not going to exhaust all the resources. We're going to do a little mini controlled nuclear test on this machine, okay? Alright, let's get started. So, what we're going to do here is we have a program called Step Bomb. This is a step-by-step fork bomb. There's a lot going on here. I'll break it down line by line. I'm going to scroll right to this line. There's a function called bomb, and bomb calls itself and pipes it to itself. That is the essence of the fork bomb. You know, colon, pipe, colon, ampersand. This is bomb, pipe, bomb, ampersand. The only difference is our bomb function takes a couple of arguments. It takes two arguments, a number and a name. And we use that as identifiers. We're going to print that out. This is just for our benefit. So we started off, we are at number 0 and our name is none. We don't have a name yet. So when we run, we increment the number. So then we'll call bomb with the number 1 and the left side, the number 1 and the right side. We'll be able to keep track how many layers deep are we, that's what the number's for. And if we're on the left side or the right side of the pipe, that's what left and right are for respectively. And then right here, this is our safety, okay? We got the safety on. When number reaches 6, when we've iterated from 0 to 6, we are going to quit the program. When it gets to 6 layers deep, there's a lot of processes running, okay? So this is just arbitrary. I've picked it because it's a good way to show what's going on, all right? And then we print F here. This is a little bit confusing, but what we're printing is just what's going to be happening. I'll show you. It'll make more sense when I actually run it. There's going to be a lot of output, but let's go for it. We're going to run step bomb. It's going to run up to 6 layers deep, and then it's going to exit. So, step bomb. Bam. Okay. As you'll notice, the program finished before stuff was running. A bunch of the output is out of order. You can see there's some 6s and some 5s here. There's a lot going on. Because everything's happening asynchronously, it's being forked in the background, a lot of things are happening out of order. But luckily, because I put the number first, we can sort it. So that output was going to standard error, so it wasn't being piped into anything. So we have to write all standard error to standard out, and then we can sort it, and we will rerun it. Okay, so what do we have here? We have 0, and then 2 1s, and then 4 2s, and then 8 3s, and then 16 4s. Take my word for it, there's 16 there. I'll prove it later. It's growing exponentially. When we get to 5, there's going to be 32. When we get to 6, there's going to be 64, all right? It's growing exponentially. It's pretty gnarly. I can prove this, which is cool. All right, now the prompt's going to get a little bit out of hand, so I'm just going to set a new prompt so I don't overflow the screen, because I know you're probably watching on your phone. And yeah, let's give you some more room. Okay, so we got a nice small prompt. What can we do? Well, we can run step bomb. We can put standard error to standard out, and then we can sort the output like we did before, and let's just get the first field. The first field is the number. This is how many layers deep we are. We got rid of the left and right. We got rid of the word running. We just have the numbers. Why do we have this? Well, we can pipe it to unique-c. This will do a frequency count of how many times they show up. So what happened here? Well, at layer 0, there was 1 running process. At layer 1, there were 2 running processes. On iteration 2, there were 4 running processes. On iteration 3, there were 8. On 4, there were 16. When we got 5 layers deep, there are 32 processes running. When we get 6 layers deep, there's 64. That's crazy. The reason it's crazy is because if we got to 7, we would have 128. If we got to 8, we'd have 256. It's growing exponentially. Each one of those is a process that's going to be running. You're going to exhaust your system of resources if this continues. Luckily, we put that safety in there to stop when it got too high. We can verify that it's exponential growth because all that means is, let's say 2 to the 0, I'm getting the number 0 here, should equal 1. So 2 to the 0, oh no, I shifted it. 2 to the 0 is 1. So 2 to the 1 should be equal to 2. 2 to the 1 is equal to 2. Cool. 2 to the 5 should be equal to 32. 2 to the 5, 2 to the 5, 32. There you go. So 2 to the 6, which was the next one, 64, obviously. And like I said, it would just keep growing exponentially if we were to let it keep going. So yeah. This is why fork bombs are dangerous. They will just keep growing exponentially. Luckily, we had a trigger in there to stop it, but we had all those processes running. We had a lot running. So yeah, hopefully that was useful for some of you.